Alan Kay's talk at UCLA 2024 in February. Well, I didn't know he was giving talks still. Hello, I'm Chris Athanas. I'm a KMP developer. Tech support said they're coming out for that, and it'll be closed up, guys, and we're done with it. And I'm a big Alan Kay fan. When you Yegor Bugayinko was like gateway, kind of like made me understand what Alan Kay was talking about because he had to bring it into a modern language. He put it into Java and JavaScript, and he explained it that way. And I was able to convert that into Kotlin and seeing how you can apply these things using Kotlin. All of Alan Kay's stuff easily applicable. And we haven't really seen the revolution yet. And I saw this talk come up. I didn't realize he was still giving talks. This is from 2024, about last year. And I didn't know he was giving real talks again because he's super old. We're gonna do a watch along. I'm gonna watch along with you.
Okay. Everyone.
Yeah, he's all
here today
great
with
out.
Alan Kay. We're at the UCLA Connection Lab with Professor Kleinrock and the rest of our students here.
Super old now.
We're very lucky to have Alan, who is presenting on a broad range of topics ranging from technology, society, and future research. And I'll keep it short. So Alan needs no further introduction. I will let him begin right away.
Thank you so much. Okay, onward we go. So the way this started off is my long friend, Len Kleinrock, sent me an email saying I'd do a talk, and I wasn't sure.
Yeah, he hasn't given talks in a while.
About the view of the car, basically about everything. Most rewarding work of my life. I'm 84 years old, guys.
Yeah, he's 84. He's the same age as my dad. It's like, holy crap.
I'll do it in just a few minutes. And of course I said, okay. And the wonderful Jason gathered up a bunch of questions, and
all right,
I endeavored to look at all of them and combine them in one way or another. But the short answers here are: is it still feasible today to do something like Xerox PARC? And the answer is yes.
Yeah, it's feasible, but possible. I don't know. People are
know of anything like Xerox PARC in the computer realm of things. They're all so goal oriented.
Yeah, they have to be goal oriented just to get funded because these things can go off into nothing forever, and usually do. So what was the magic spice? Well, the magic spice that was the serendipity with Alan Kay and all of experience and all the people that came before, and how he just gathered these minds around him that were somewhat aligned. It was, how do you recreate magic? Lightning in a bottle? I don't know.
But there's a great biology institute funded by the Hughes Foundation called Genelia Labs near Washington, D.C. And there's the Max Planck Institute. And we'll see a little bit why I don't consider there's a lot with the same kind of spirit as Xerox PARC. And as I'll say in a moment, it wasn't Xerox PARC. Xerox PARC was part of the much larger ARPA research community.
Yeah, big community.
And considered it was just by Xerox because the Department of Defense had quit funding ARPA the right way and put the D on it and changed everything. So we'll see about that in a minute. And
he kind of hacked his way in on a defense project, big deep pockets. So yeah, but he I think he turned into something good, more than evil. Let's keep going.
Short answer: I believe young people today have to solve a harder problem and require resources. And my answer is yes, absolutely. It is much harder. As the businesses have moved in, which started really strongly in the 80s after the inventions of personal computing and pervasive and local networking.
Let's be real, it's always been business, but like niching down is what he's talking about. Let's keep going.
There was something that could be, and the GUI, which opened up the computer to the rest of the
Yeah, some crosstalk. That's not me.
Sorry, go ahead.
I could hear people talking.
Yeah.
Yes, so it's much harder. And
right, there's not as much low-hanging fruit, I'll agree. But we also have more tools and ways to go niching down. So we're trying to build, try and do something new. You might have a hard time with that, but like implementing some of his ideas, I think it's never been easier.
There wasn't a time to really answer these completely separately, so I sort of wove them together. And I like this one. This is a recent one. What are some of the most tragic illusions that adults get stuck with?
Yeah.
That is the most flattering thing I've heard in years because it assumes I'm not an adult, which I'm not.
Well, you have adult-like features.
Xerox PARC
Alan, you have adult-like features. I don't know if he's an adult fully agree. I might agree with him after listening to hours of his lectures and reading and understanding his material. He definitely has childlike qualities, but yeah, let's keep going.
For them. And then there's this ... one, which I did do a little prep on it, but I left it to the end in case we run out of time, because in 84 years, I've had a lot of aha moments. But let's start off with number one. This is part of the tragic illusions. What we're doing right now and what we do in most classrooms is to recapitulate something that happened 150,000 years ago, which is a bunch of people gathering around a campfire listening to somebody talk. And just think about it for a second. How crazy is it for me to be doing what I'm doing now? This is why I've sent a couple of papers along to read. It's crazy to orally discuss ideas and inventions that required reading and writing to invent and to explain. The oral medium is not good for the best of the stuff that we do.
Yeah, rhetoric doesn't quite 100% fit.
But we all have the same pink brains. They love stories. And so what this guy wants is a story. And
what we're looking for is metaphors. Metaphors. Tell me a story that links up the metaphors so I can relate it to the thing you're talking about into something that I already know. And can you link it together in a way that makes sense? Give me the reasoning behind it. That's what a story is, right? Let's go.
What I'm trying to do is to apply to tell stories about things that really aren't very good as stories. Yeah. And the problem is we're still basically the same species with the same pink brain that wants stories.
Yes.
And systems aren't stories. I'm basically a systems guy.
Agree. Yes, this is
the difficulty. If we take a look at what happened going back a few 100,000 years, human genetics, it's changed a little bit. Some of us got to be able to digest milk and so forth. And human inventions gradually took off. And with modern theories about origins of languages, a lot more of language seems to be an invention via culture than we thought in the past. And then we have this problem, which I hope you can see there because my little thing is blocking. Our collective wisdom started being informed by our inventions, but it grew at a much slower rate because the inventions are various forms of technology, including symbolic technologies. And they turned out to be really easy once we got the hang of it. And so we've got this huge gap. So we can turn the guy's spear into a tomahawk missile. We can increase his power of destruction by a factor of 1,000,000. And we can do something much worse, which is to turn him into a bureaucrat and create bureaucracy. Bureaucracy has killed millions.
Alan. This is why he's not well liked. This is why I love him, but he's not well liked by the powers that be. I guess they don't want to hear this stuff, but he'll see
millions more people than the worst atomic weapons.
Absolutely.
So
100%.
This is a huge problem.
Absolutely. People working in groups with mixed incentives that they don't quite fully understand what the implications of. Oh yeah, bureaucracy, millions of dead. Yes, extremely deadly. This is the first time I've heard Alan talk about that. He's spot on.
And education is supposed to do something about it. We'll talk about that a little bit later. But think about it. We just went through the inability of most of the population of the planet to not understand how viruses and diseases work. That was botched almost everywhere. And in the last 60 plus years, we've been ignoring something smaller than a virus, the CO2 molecule, which is gradually changing the entire planet that we live on.
Well, we'll see.
So if you're looking for human wisdom,
can't get them all right.
It's not up to the scaling of what we've been able to invent. Okay, so cliff notes for human beings. I'll do this quickly, but so we're basically Hamlet. Our minds are like theaters.
Yes.
We're more theatrical than we think. We create
yes, this is our survival mechanism. This is what we're built on. This is why it got to where we are, is that we have a brain that can simulate other people. And that gives us a skill and a strategy that other animals are lower. If they can only simulate themselves, then they're in this lower position. Because as predators, and we are predator species, because we got the eyes in the front, all the reasons, we need to work in groups and with people. And we also have to know what the prey is going to do. So that we have to put ourselves in the mind of the prey and what everyone else is going to do to survive. And we didn't do that, we wouldn't be at this position. Let's keep going.
Treat our beliefs as reality. That is the worst thing about human beings.
Well, we have to do it though. That's the thing. It is sucks. This is our hardware software combination. But yeah, we got to believe in something, and we'll take shortcuts just to survive. Yeah, I know it sucks, man. Alan, I agree with you. It's this hardware and software has some severe limitations.
And these theaters are tiny. We can only think of a few things at once. It's hard for us to take in larger things.
Right.
And if you look into biology, we find out
7 plus 2 means our short-term memory can have 7 plus minus 2 items on it, and so we can think about 7 plus or minus 2 for depending on your IQ level, how much you can take in at one time. You know, and all the cultural factors, all that stuff is still small, still stack, tiny little stack, man.
Yeah, that most of our mind is not human, and we're more non-human than we assume.
Right, we have a reptilian core, which is all this predator stuff that made us survive, because we went through several of these evolutionary gates. The people that are here, that you're alive and you're listening to, and we're talking, we have survived some serious evolutionary gates. The Black Death, the Purge. I mean, we were in a line of the survivors of that. People forget this. We were survivors of some really fucked up shit, man. So our mind is not necessarily tuned for what the commercial demands for modern day business social interaction is set up for. Let's keep going.
We tend to react much more than actual thinking. Thinking actually had to be
Yes,
invented.
we have to react, because we don't have time to take it all in. We don't have time to. We have to go to work, right? But we don't have time to ask every person in the community about what I just saw, about what that thing was. Now we used to be able to get a wisdom from that, but that's been broken for the industrialization process, the commercialization process, the financialization process. So yes, we've now running on this society that has these strange, perverse incentives, and they're gonna. A lot of them are gonna fall over, and we have to examine them, and after it's fallen over, and go, what happened, and then maybe we can change a little bit. Usually, implies a lot of pain. Let's keep going.
We grow up in whatever culture we were born into,
right?
And that shapes so much of who we are, and also how we look at the world.
Absolutely.
Our conclusions tend to be societal. That's a disaster.
I mean, yeah, because society is the mob, and the mob was kind of crazy. It's like our base desires, and then we have people like Edward Bernays who took advantage of this stuff and hijacked our emotional system for commercial gain, and also to start wars and create nations and topple nations. What? This is crazy. Where are we living in? Yep, here we are.
And we have not just one mind, and really not just one brain. We maybe have about 80 different conglomerations of things that could be called brainlets.
So it's like Marvin Minsky, the society of mind idea. I think it's even more like it's unlimited. I think you could probably categorize stuff into these 80 little categories, but we're this organic process who's just, our main thing is we're going to survive this thing, and we're going to reproduce, and we're going to keep going, and I'm going to eat, and I'm going to drink, and I'm going to breathe. And if somebody stops me from doing that, I'm going to do something about it. It's like we're an organism, man. There's a lot of stuff that we do don't make no sense.
We have a special set of ones shared with most animals, which is learning by touching things. We learn by seeing things. We have a completely different set of knowledges from how things look. Yeah. And we have the symbolic mechanism, which is both our downfall and our salvation.
Mm-hmm.
So we're much more fragmented. We only have one body, but what we want actually conflicts internally.
This is a great presentation. This is the first time he's done this presentation. This is a new one. I haven't seen this stuff like presented like this, so I'm having a treat, y'all.
So this is a whole area that's really worthwhile studying, especially in this age of computation, and especially this area. I'll leave it at that. Now let's go to the second question: is what did we ever do for Xerox anyway? Well, we'll talk a little bit later about where Xerox PARC came from, but here are some of the things that we did.
Almost all the stuff we're using right here.
Like a modern personal computer.
Take for granted.
The GUI with icons and pointing. Basically a way of dealing with symmetrical reading and writing that was also what you see is what you get. What we have to call real OOP today, that we only called OOP back then, but it was a different than what is called OOP today.
Yeah.
And we did the laser printer, which just for
which I go into detail in my course, free course, by the way, how to program from the ground up. I talk about the differences between the COP and the BOOP, which is talking about his OOP, which is BOOP. I call BOOP, back to object-oriented programming, versus the Bjorn Stroustrup's the crazy C++ COP, class-oriented programmer, COP. Let's keep going.
Engineers in the crowd. The very first laser printer was a page a second, which most people have never experienced today, at 500 pixels to the inch. So that is a great story all by itself, how Gary Starkweather did that. The outline fonts and PostScript, the Ethernet, peer-to-peer and client server, and about half the internet. PARC actually had its own internet, which is called the PARC Universal Packets. It was spread all over the country, and about, I don't know, half the general meetings that were held at UCLA especially were done by PARC people, some of whom had already done some of the things that we're getting. The thing is that all of these things came out of a particular community. So we like to claim we had 8.5 visible inventions. And of course, what's interesting about all of this is all the technology that had to be invented that was invisible. And according to Butler Lamson, this was done.
All that tacit knowledge. This is just the surface tiny, the actual implementation of the surface things. There's a whole body of knowledge underneath it, psychology, all this stuff Alan Kay's talking about, culture, like how humans look at things.
With about 25 researchers over about 5 years, these particular ones I'm showing here. And the park itself intense. Existed in the form it was for about 10 years.
But I mean, typically said some of this stuff was low-hanging fruit that we were going to do at some point anyway, like the networking stuff. We're going to get that. But bitmap screens and the GUI wasn't very obvious what that was going to be a winner. So, but like things like Ethernet were going to come along anyway. But some of this other stuff, like especially the GUI, there just wasn't anybody even thinking about that stuff at that time at all. Like not even at all. Like thinking didn't make that was like they'd be considered a waste of computing resources.
So in total, today's dollars here is like, I don't know, 15 years ago or so when I made this.
Because I remember the time when I was still pre-GUI, and when we were talking about this new GUI, like the graphic interface on Mac, it says that's a toy for children. It's not a real computer. All this stuff was around, even though it was way more powerful. You could do all kinds of stuff that just wasn't possible to do on regular desktop machines, like pre-GUI desktop machines. I remember people poo-pooing it like it was a toy or goofy or pointless. It was a thing, man. It was crazy how people really buy into some permanent current implementation and just won't let go of it no matter what comes along.
So it was in dollars of 15 years ago, it was about $10 million a year, or about 100 million to 120 million for the 10 years. And Park had 4 labs. So there was system science, computer science, optical science, and physical science. So this is the total budget of Park. And when I first did this slide 15 years ago or so, the return was about $35 trillion to the world. Now I think it's up past 50 trillion or so.
Yeah,
to get back to the question is, and this is an important idea. The thing that confused people and confused Xerox was if you can look at these 8.5 inventions, you see an industry.
Yeah.
It is the basis of one of the main large industries
that
we have.
It's the bottom technologies that allowed things like the internet to happen. Now we've explored almost the entire space of stuff. What I see now is niching down into more applications as opposed to the broader, bigger, low-hanging fruit. There's gonna be more deeper stuff that's not going to be as lucrative, but with a smaller team may be possible, which is I talk about in like Micronopoly and adventure-driven development courses or classes or series, whatever you want to call them.
Today. Now, what about return to Park? Well, Xerox missed most of these, but it doesn't matter because the return on the laser printer all by itself was about a factor of 200 on the entire investment.
It was shocking that Xerox didn't take this and went with it. All they knew was printers and all they knew was copiers and paper because that was their winter product. That was their flagship. So the whole business was around it. So there must be like Conway's law about the product that gets created. Like what else did? Who else did it? Panasonic. Polaroid also had the same thing, right? They had the technology. They even invented it. They invented the digital camera. They just let somebody else take it. Any one of these technologies could have been spun off by Xerox at the time, and they were just sleepy, like, no, we don't care. They could have been spun off into whole businesses because that's eventually what happened, and they just slept on it. It's just shocking, and it's also a lesson because there's lots of companies today that are doing the same thing. This flaw in human nature has not changed, so there's lots of opportunity around to rewrite these things without the cruft and garbage of the bad previous ideas. Let's keep going.
Over the entire 10 years. So Xerox made billions and billions just from this one thing. They missed the trillions, but if you look at it from a positive direction, thank goodness they were willing to fund people that no business person in the right.
Right. It was very lucky. Let's also go to the other side. If somebody was enlightened enough to hire Alan Kay to do these things, because if it hadn't have happened, it would eventually, some of the stuff would have already happened, but some of the stuff definitely wouldn't, because there's really still nobody really talking about what Alan Kay was referring to, except for Yuga Boogie. There's a few, but nothing at the stature like No one that should be like, hey man, Alan Kay kind of answered a lot of the questions back then. If you just listen to what he has to say and not be so complete performance, it's like, man, it's hard to get people unstuck. But that's why the computer revolution still hasn't happened until we get stuff what Alan Kay was talking about. It still hasn't happened yet.
Mind would fund. So we got what we got. Now, the real story here is that back in the 40s, the Cold War started with the Russian A-bomb after World War II, and that gave rise to a bunch of DoD funding, which included Whirlwind, which we'll talk about in a minute, the SAGE air defense system, we'll talk about in a minute. And then in 57, Sputnik came along, and that created ARPA. We'll talk about that in a minute. And here are some of the things that ARPA did up to the time when the Vietnam War and Congress decided to kill ARPA funding for public domain computing. So you can look at these yourself.
Not private domain, though, or just government, proprietary.
Personal computing, computer graphics, packet switching. That handsome guy in the packet switching thing on the right is none other than Len Kleinrock, looking very confident, as we all were back then. That led to the ARPANET, and that led to the...
Well, they're hitting the low-hanging fruit. It was like amazing. They were able to pull off some of these things because no one had even seen anything like this before. So they thought they were on top of it. It's like, nah, this is just level one, man.
Internet, and the first tablet was really good one that was done back in 1964, and then there was the Engelbart system and so forth. So PARC was actually set up because one of the deputy directors of ARPA, IPTO, feared that this work was not going to be continued to some kind of fruition. So he started looking around, and it happened that Xerox was looking around for a long-range research lab, and they got together, and the lab was put as far away from corporate headquarters as possible.
That's awesome. Smart.
Next to a university. So it's either going to be Berkeley or Stanford. They put it next to Stanford.
That's cool.
PARC.
Somebody people older, they had some smarts, but and a level of like adventure driven like outlook as opposed to this, I gotta have a goal, and if you don't make the quarterly blah blah blah, we're gonna cancel you. Like no open-ended exploration at all. Leave that to the tinkerers and small players. Oh, man, here we go.
Thought of itself as being part of the ARPA community. Almost every computer researcher there had been a graduate student and had their degrees paid for by ARPA and so forth. So I never talk about PARC without bringing in this larger context. And in fact, the larger context was the reason that PARC was able to do so many things with so few researchers.
Yeah.
There was all of this prior art available in the research community.
And to be fair, a lot of it is low hanging. Let's not get ahead of ourselves too much.
Community, and the research community also taught the grad students how to work together. I'll talk about that in a minute. Okay, here's feedback from the world, pushback. Look at some of these numbers are dismally low. Like here are the heartbreakers. On the other hand, 100% of the internet, 100% of the Ethernet, 100% of the laser printer, outline fonts, peer-to-peer, and all that stuff.
How much has
accepted, and this is in large part because there weren't good solutions already out there. The 50% on the modern personal computer is because the people who adapted this to the commercial world basically adapted it in its appearances. They didn't look any deeper.
Right. It was just the appearance of it that we have. That's why he's talking about how the computer revolution has not happened yet because it still hasn't used his stuff. We just have the appearance of his stuff, which is like a part of it, but not the main part. Believe it or not, the main part was this language and how everything is interrelated and you could change anything. Let's keep going.
Most of the hackers in the 80s thought they knew how to program, so their interest in doing really new ways of programming was very low. So the least accepted thing was the way
it was a performance thing. They were trying to just get these machines to do something useful so they could keep their market, keep in business. They weren't thinking about how we can enhance the user completely. We just wanted to give it tools that we can make money on and not do this revolution that he keeps talking about, which I'm excited to see at some point. Hopefully I'll still be alive when it happens.
He did successful software at PARC. And some of the deepest ideas that our field has ever come up with were done by Engelbart and his group. And almost none of those have even been understood. And if I were there in person, what I always do is ask students what Engelbart did, and they usually can't tell me. And it's hard to find a student. In fact, let's do it right now, just for the hell of it. Okay, students, can you hear me? Raise your hand.
The collaboration stuff.
Okay. Let's see. What do I want here? Yes. So students, please tell me anybody who's typed ENGELBART into Google. Raise your hand.
I think one hint is Professor Glenn wrote.
Well, of course. Okay, so this is basically being in physics, being a physics major, and not being curious about Newton. So this is not an exaggeration.
To the hypermedia stuff,
Think about
hypertext stuff.
And if you want some bitching
first
from
demo, they call the demo.
a lot of us back in the old
mother
days
of all demos or something.
put out a lot of effort, including Len in the room, to get you guys personal computers, which you have with you, and to get you guys networks that can connect to things, and to get you so you can be just a few characters and a mouse push away from satisfying your curiosity about the heroes of your own profession. Think about that, and none of you have done that. What do you think about that?
Got a little spank from the professor. Oof.
Okay, so let's now go quickly back again. Russian A-bomb. Well, here's Whirlwind.
For doing radar tracking for missiles coming from Russia. And bombers.
This is just a few racks of Whirlwind at MIT. It was actually just a 16-bit parallel real-time mini computer, but it took this amount of space. It had about 5,000 vacuum tubes. And the memory devices back around 1950 were so bad for storage, for RAM, that it forced one of the guy in the middle there, Jay Forrester, to invent core memory, which was the technology that let computers go commercial for the first time.
Yeah, they were doing
the guy to his
drums, I think.
Let's see, to his left, the guy who's standing behind them in the middle of the picture there, Jay Everett. Whoops.
Which one? He's 84, guys. Let him cook. Let him cook.
I hate Zoom. Okay.
Zoom. I don't like Zoom either.
Okay. Also with this was one of the earliest displays, and Everett had actually.
What are we doing?
Sorry,
Professor K.
Everett had actually invented a way to point at the screen.
Oh yeah.
And this was as far as I know, the first time there was computer graphics with a pointing device. And they did this because the Cold War changed their original theory about what they were doing, which was to make flight simulators. And they were starting to lose their funding for that. But the atomic bomb of the Russians got the military interested in whether you could hook a computer up to radar and track it. And they were the first to do this. And that system that they built back then morphed its way into the worldwide airplane tracking system that we use today. Then the second phase of Whirlwind was to go all out and see if we could track Russian bombers before they could get to us. And so they built these monstrous blockhouses out of concrete. This is about the size they were. Bottom floor there is just a power supply. The second floor here are two really big Q7 computers with maybe 55,000 vacuum tubes hanging together. They're really something to walk around in.
I can imagine.
So 24 of these were built in the US.
Wow.
And then up on the top floor were 100 to about 150 graphics terminals with pointing devices for dealing with various kinds of information. And here's what one row of them look like.
Yeah.
So there were zillions of them.
That was the pointer device. That's where the mouse idea was, like original core of where the mouse idea was coming from. Was with this stuff.
57 now.
The pointer.
And they had a network. It wasn't a great network. It wasn't a packet switching network. But they'd gotten used to the idea that if you're going to build computers and have people work together, you better have a network and some way of doing that. So this crowning glory was just coming to fruition when the Russians decided, oh, well, let's just shoot some rockets to show the Americans that we don't need to deliver bombs by a bomber. We can make ICBMs.
Yeah, Sputnik.
So this shocked the nation and Congress, and they set up ARPA, Advanced Research.
Yeah, I think what shocked them was how early they had this achieved, but it was kind of expected because the Russians had a rocket program and a nuke program, and the Americans had a rocket program and a nuke program, and they did eventually share information. So it wasn't like fully unexpected, but they had to act. I think they had to act like it was unexpected to get the funding to ramp up more of the Defense Department stuff. Let's keep going.
Projects Agency. The director in the early 60s was Jack Ruina. And he decided to give this guy, Jacob Licklider, known as Lick, some leftover money they had, which by DoD standards wasn't a lot, but by computer standards, it was millions.
And yeah, the military contracting. Oh yeah. Oh yeah.
They gave it to him because they liked him. And you'll get an idea about this soon. And so here are the 1960s directors of ARPA. Not a military person among them. These are all PhD scientists.
Okay.
And the 4 ARPA computer research directors were all scientists. And this is
this guy Evan Sutherland. He's the one that gave us all the GUI stuff from the beginning. He was the first one. Really influential guy.
Because the powers that set this up realized that having something like the military and something like Congress with a dire threat that they were trying to deal with would just botch things up. Still true today. So, but of course, Congress ultimately controlled the budget, but they didn't have much power because the Americans were frightened of the Russians. And so they weren't going to curtail military spending. But people in Congress would say these words that everybody has heard still today, how is this relevant? Tell me why this work that you're doing is relevant to the Department of Defense. And they would get pushback from these scientists. Jack would say, that's not the right question to ask. Bob Sproul Sr. would say, the right question to ask is, how is this going to help the United States or this technology or our society or our culture generally?
That's not what the military is interested in. We're Department of Defense, not Department of Culture, Society, and generally our culture. No, we're trying to defeat the freaking Soviets while working with them. This makes... keep going, let's keep going.
Holy shit. Bob Taylor's remark was, they would stand up to these guys and in a polite, civilized way attack their myopia because these ARPA directors were scientific statesmen. And Bob reflects, we've had too few of those people in the job since then.
Yeah.
And around 1966, Charlie Hertzfield asked Bob, well, what do you want? And Bob said, this network is what I want to do, and here's why. And Charlie said, okay. And Bob's recollection, that was a 50-minute conversation.
Well, I mean, okay, so the threat of nuclear war was happening. I'm sure it was like, look, there is a way we can make secure communications. So even in the case of nuclear war, where like 80% of the country's wiped out, we can still communicate. And it'll be automatic and blah, 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 and packet switch and high proficiency and voice and data and everything else on top of it. And everything is a universal substrate. And then we can expand it from here. And it'll have direct material military applications. But eventually there'll be some cultural stuff. Maybe not. We'll see. We'll see how it goes. And that was the conversation why it only took 15 minutes. Because of the threats that were coming from the Soviets, the supposed threats from the Soviets.
Charlie asked, how much money do you need? And Bob said, well, $1 billion or so. It's like $7 or $8 million today just to get it organized. And Hertzfeld said, okay. And Bob's recollection was that there was no actual ARPA paperwork order written or anything for months, maybe even a year.
Cool, man. That's adventure driven right there. This would never happen today. Oh, well, I mean, this was just a very, very special time and very special circumstances that allowed something like that to happen. But I guess over in history, this is sort of how things go as well. All these companies, all these empires and stuff still have humans in charge of all this stuff. And sometimes it works out and sometimes it doesn't. And it was lucky that these guys are all very competent, all very serious, not screwing around. And, it was a different time, a different age. And they still had this like cultural American nationalism thing happening in mindset. So they were competent people. They were highly skilled. So let's keep going.
These people all trusted each other and did a lot of things very quickly this way. Now, a key idea here, if you can see him, is that Bob Taylor, after ARPA, went on to be the founder.
That's why
of the computer science research at Xerox.
He was already involved. He was already knew all the stuff. I'm glad I watched this video because now it all makes sense. Like, why did Xerox get all this ARPA shit? I was like, oh, it was basically an ARPA program. Okay, now it makes sense. So if it wasn't for the Department of Defense, we wouldn't have the desktop. So we can kind of thank the government for having desktop machines, the GUIs and stuff. All right, let's keep going.
So he was the connection.
Your tax dollars at work. This one kind of worked out, I guess. We'll see.
And of course, the computer science research at Park was set up like the computer science research of ARPA. And so when we look at this, We want to see what did these people way back then think about this that Mark was set up.
Oh,
like
I have my thing in the way. This guy.
And so when we look at this,
it's the same guy.
We want to see what did these people way back then think about this. We have all these questions that we can't answer all of them today. We can look at the first couple there, and we can get a couple of samples of what they were saying. So Vannevar Bush, pronounced the way beaver is pronounced in New England, Vannevar Bush, who was President Roosevelt's science advisor, said in the 40s, wholly new forms of encyclopedias will appear, ready-made with a mesh of associative trails running through them, ready to be dropped into the memex and there amplified. So that got a lot of people thinking. Licklider said, in a few years, the combination of humans and computers will think as no humans have ever thought before.
Well, I mean, okay, this inspires engineers, inspires people, like which way we want to go, how we want to go, what we want to attempt, but we always have this dream of having this machine that gives us the super intelligence. We always have it, and we think that will be the end of it. It's like, man, no.
John McCarthy looked at the SAGE system and said, every home will have one and with an intelligent interface.
Okay.
Because he thought, the way McCarthy thought about it is, well, this is just like getting gas and water and electric power and so forth into a house. It's a utility. So every house will have a terminal connected to a worldwide utility.
Maybe.
That was 1958. That affected the work at MIT by Corby, Fernando Corbato. Ivan Sutherland, the inventor of computer
graphics, the shit, man.
Graphic input coupled to some
his stuff he talked about. That's exactly what we're using today.
Kind of computation, which is in turn coupled to a graphical output, is a truly powerful tool for education design.
Agreed.
And Engelbart here said we can boost mankind's capability for coping with complex, urgent problems by augmenting the collective IQ.
I see what he's trying to do, and I guess it kind of has that way. You can find people you'd never normally find and get a user group, but there's also the other way around too. So we can also destroy mankind's capability for coping with complex urgent problems by augmenting the collective IQ of really dumb people.
IQ of groups, not just augmenting people, but augmenting groups.
Yeah, the bot networks and all this state level sponsored AI, half not real people. Yeah, okay.
And I'm going to concentrate more on these two, but we'll get a look at a bit. Okay, so
I like to use these things for good, but they're often used for evil before there are people wise up. It's like, oh, okay, there's limits to this. Like, yeah, there's limits to all these things.
What were these guys looking for as far as people? Lick was just looking for the best people. Ivan was looking for people who could choose their own problems and methods.
Adventure driven.
Taylor thought his job was to fix up
adventure
the social
driven.
So that when the lone wolf.
Bob Taylor, totally adventure. No wonder they had success, because Bob Taylor is a totally adventure driven guy. Yeah.
Scientists needed to cooperate. They will. And Larry said everybody understood the game.
The military is the country. The country is the military. This is something people don't want to look at. The nation is kind of the military. Like, a lot of these businesses are set up in a very militaristic way. The schools are militaristic. The whole thing is like very militarized, and people don't want to see. It's like, no, it's social, and we're gonna help out grandma. Social Security's like, no, man, this thing's all military operation, conquering and holding territory. Oh yeah, that's military. Let's keep going
here. Which was ARPA IPTO was allowed to help the country as long as it was helping the military. And so what kind of people were they looking for?
This man right here is my great-grandfather. He's the first cat herder in our family.
Cat herders.
Don't let anybody tell you it's easy. Anybody can herd cattle. Hold them together 10,000 half wild short hairs. That's another thing altogether.
Cat herders.
Well, you get the idea. And so the real question here is, what if only cats can do this stuff and adults don't get it? Adults are into command and control doesn't work with cats.
Have a jar full of other toys we have sitting right next to us. And we'll take one jar one by one, open up these toys. All right. Would you like to go first, picking something from the jar? Yes. All right. But now it's on a spring. I like this one. All right. Me too. All right. It's inside this box right here. So there's this little mouse on a spring, and it's going up and down, and cats are going to try to catch it. Alrighty. Our cats really like having mouses, but they keep on tearing them apart because they're kind of vicious. So we got another one. Okay, I got it. And this is the toy, the little mouse. George is already sitting. Like, what is this? What is this mysterious item, George?
I think you get it. Gotta have some feel for what cats want.
Yeah.
So Lick pointed out right at the beginning that great visions are not the same as goals, but they are the ultimate cat toy.
Adventure driven, yes.
So
I love this way he's put it. Great visions are not goals, but the ultimate cat toy. That's the epic goal, the epic journey, the epic quest. Yes, it has to be a little further away and probably out of reach, probably unattainable.
To this vision, just not phrased as a goal. He said, computers are destined to become interactive intellectual amplifiers for everyone, universally networked worldwide. He did not know what this meant. In fact, he was a psychologist, not a what we call a card-carrying engineer, but he understood a lot. That if you take this vision and stick it behind a mountain range, it sends out a magnetic field, which is Marvin Minsky like to point out. If you don't know what to do, he's got do lots of things. That's what Lick was doing. And so the number one principle here of doing anything like this, where you are going to have the possibility of really large new things, is the goodness of the results correlates most strongly with the goodness of the funders. That is my
it always comes down from the top, man. That has to do with the people in charge are what the results will come out. If the people in charge are trying to scam or trying to grift or just copycat or whatever, we're just phoning it in, you're gonna get those results. They're gonna look chintzy and crappy and cheap and half done and not nobody really cares. But if you have people that in charge that actually care and they think they have a vision themselves, and they kind of have insights about how to do it, and they get lucky, right time, right people, right circumstance, right technology, right curve, adoption curve, stuff built that we can keep going. Sometimes you get lucky.
From the past, because every era has really smart people. I've never been in an era that didn't have people as smart as the people I worked with back then, but the funders were wonderful in the 60s and
the circumstances.
70s, and they've been ever more terrible ever since.
Yeah, for very good reasons.
So two of the main things
incentives
that came out of this was humans and computers working together as an idea, and then this larger idea of augmenting human intellect in general. So I'll just go through these quickly. There's a million of them. They're in one of the papers I handed out. But basically, go against conventional wisdom. Do visions, not goals. Let somebody else do the goals. Fun problem finding, not just problem solving. This is a key one because a problem is often too rooted in the context of the present. And so if you're just doing that, which is kind of what's going on, this is what NSF likes to fund.
So he's talking about like a research institute. For adventure driven, the problem finding is going to have to be unfunded. You're going to have to do that on your own. You're going to have to just be aware and be awake and be paying attention to the things around you that you can pay attention to. But in research institutes, yeah, you're going to have to fund the problem finding. Yes.
Problems that peer reviewers can understand in the present. And most of them don't make contributions. Problem finding, on the other hand, is difficult for everybody, but it gives you a chance.
Problem finding in a domain that could be possibly solved. Okay, let's keep going.
Fund people, not projects.
Nice.
So in other words, don't even worry. If you've got some crazy guy who's really good, or girl who's really good, don't worry about what they want to do. Give them some money and see what happens. Corollary, fund the very best people.
Right. This is a hands off. You have to let go. People have to let go of power. You're funding what now? We're funding this guy. Well, what is he gonna do? We don't know. How much trust do you have to have in somebody to be like, okay, well, let's see what happens. Today, it's like, no, we don't think so. So you have to kind of do that part on your own. For micro monopolies or adventure-driven development, he's talking about something else.
I don't think that's being done today. And an important part of the research results are new and better researchers. And
yeah, it's completely skipped.
In a sense, NSF is paying for some of this, but I don't think a lot of research is being done. I think it's mostly engineering. So what I think is what NSF is paying for are new and better practical engineers. Right. What we need is new and better researchers.
Oof. But we might have to have a technology on some of the base layer we can build on, because this electronic stuff, the digital electronic stuff, I think we've kind of might have come to the end of it. Maybe we can niche down some more, but I think we've come to the end of like what we can do with these damn things. We need to have another spurt of somewhere from technology spurt, not just the AI stuff. This is something else.
Really advance something very important. Well, that's controversial because it probably is something new. And here's a key one: design and build in the future and bring back to the present.
Yeah, I think this operating system, Alan Kay, this like whole operating system based on Alan Kay stuff, that would actually unleash a bunch. But I've not seen anybody working on that. I think people working on Smalltalk, but they're not working on an operating system from the bottom up, like what Alan Kay's talking about, with new ideas in it, not trying to make it small talky.
And one that costs a lot of money was make enough of the inventions and in a practical enough manner so that many people can use them. In other words, live in your own mess that you've made.
That's
milestones,
hard.
not deadlines. That's a
but they were able to do that at Park because the baseline was these batch processing computers of booting up and dog fooding their own stuff. I mean, that made sense then. I don't know if it made. Let's keep going.
Okay, so here are 5 things that
tinkering.
Many things that people are the individual stars there are people get interested in aesthetics, or they prefer to tinker, they prefer to do engineering. But the problem is the sweet spot in the center is something we have to get to, because as Marvin says, you don't understand something if you only understand it
right.
once.
This has to be invested in and raised. The culture and the society that brought the things together that brought us up to this point has not been maintained. It's gone, and there's to be another maintenance of all the tinkering, of all like a drive in the culture, because what drove a lot of the 60s, 50s, 60s cultures was this whole push for science. They did the government intentionally did this whole science push. They threw a bunch of money at it and encouraged children and young adults to get involved with math and science and all that stuff. And they spent money on it, and they put training on it, and they put it on TV, and it was a big deal. Because the same thing they did in Germany, and before the mustache man came along, they after the Treaty of Versailles, they said we need to concentrate kids, electronics, mostly avionics, rocketry, and planes, design of them, gliders, all that stuff, and mechanical stuff. Then there was a big push for that, and that's after 20 years of that, like 15 years of that, those kids grew up and they started making the real deal stuff. So without that part of the society coming back or being encouraged somehow, and there was a big United States used to be a major tinkerer society, motors, engines, stuff like that, which is where a lot of these engineering people come out of, and the mathematics people come out of that stuff from the tinkering. They know they got to get involved with math, which is brings you back to science. And the aesthetic people have to get involved as well, because just because you come up with something, you got to make it usable for other people. So that's where the aesthetic stuff's coming in. Let's keep going.
This is a key phrase for the 20th and 21st centuries. And so no matter what your favorite one of these is, you have to get fluent in all of them. And this is not the way universities are set up,
or at least accepting of it. Boy, there's so many people that are in the math, they just do not accept the aesthetics people, the tinkering people, or that don't want the austerity of the math, or don't want to be tended by some sort of engineering practice. Yeah, you really do have to have a sensibility of all of them to be effective.
The way companies are set up, but you got to do it. The best people I know all are in the center here. And then there's a question regarding computing is could there actually be a science of computing? They are artificial objects after all. We're not looking at molecules or so forth. We're looking
I don't know.
At constructed things. And what does that mean as a science? So go back into the 50s again. We've got phenomena. We can see these artifacts. They've got wires and vacuum tubes, and we can program them, and we can make a higher level language for them, like Fortran and so
hardware.
Forth. That isn't really science. What is science?
No, it's application.
I've got this cryptic phrase here. Scientists try to find fireflies and make t-shirts. What does that mean? It means that behind the stuff that distracts us, there are hidden, deeper properties. The properties might not even be in there explicitly, but they're there. What scientists do is what I call good woo-woo, which is they let their brain relax to the point where they can start thinking beneath the surface of things. And here's one of the first computer scientists, John McCarthy, and he looked at this stuff in the 50s and decided to make a t-shirt of it. And the t-shirt looks like this. So it's kind of Maxwell's equations of computing. And what's interesting about it is that it doesn't look like the hardware, and it doesn't look like the software. It's actually a mathematical formulation of what John thought the most important relationships were. So I would call
as long as it's logical, it could be implemented on a machine, on a computer, because it's just logic. And it could be used relays, you can use magnets, you can use all kinds of stuff. You don't even have to be electronic. You can use water drops. There's all kinds of ways of doing it. but the logical what we're making it represent, that's always up to human ingenuity and cleverness and making itself internally consistent, insights, guessing, trying, working things out, human ingenuity. Yeah, now the hardware can reflect that human ingenuity, but it's not the human ingenuity. It's like it's reflecting that or implementing that. It's like, putting out like a birdhouse together. All the slabs of stuff's all laying around, everything's random. It's like only your human ingenuity. You put the things together, put the screws in, and paint the thing properly to make it into a birdhouse. Otherwise, it's just a collection of wooden, metal parts, metal pieces that are inconsistent and have no purpose at all.
Call this Maxwellian. And then he did something even stronger along the lines of Newton, which is to explain important ideas here about what was lying beneath the surface and why it was really useful to think of doing things in a particular way.
Interesting. Programs that learn to modify their own behaviors require a way of representing algorithms so that interesting properties and interesting transformations of algorithms are simply represented. Okay. Theories of commutability have been based on training machines, recursive functions of integers, and computer programs. Each of these has artificialities which make it difficult to manipulate algorithms or prove things about them. The present paper presents a formalism based on conditional forms and recursive functions, whereby the functions computable in terms of certain base functions can be simply expressed. We also describe some of the formal properties of conditional forms and a form method called recursion induction for proving facts and algorithms. I guess inside of the logical space, you can do these kinds of things. Instead of a self-contained symbolic association that's internally non-contradictory. Yeah, you can totally do this with math. But that doesn't mean it's actually real. It's just a way of thinking about things. Doesn't mean that actually exists. I'm gonna do this in two parts, maybe 3. Yeah, give me a like and subscribe, and I'll continue on to part 2 tomorrow.